For our last example, we'd like to look at the polynomial w to the fifth plus 3w to the fourth minus 2w cubed minus 9 over, or divided by, the two-term polynomial w squared minus 2. There's something different about this one because both the numerator and the denominator are missing terms, and by that I mean we have in the numerator we have a fifth power term, a fourth power term, a third power term. We do not have a squared term. We don't have a w to the first power term. In the denominator, the same thing is going on. We have a w squared term. We don't have a w term. We have a constant term. As we saw in our other examples, when we're doing long division, like terms always fall below other like terms when we're doing the subtraction step. And otherwise, this becomes very difficult to follow what's going on. If we try to do the division as this problem sits right now, that will not happen. So what we'll do is we will fill in we'll take w squared, the divisor, but we'll say we don't have any w's. Plus 0w minus 2 goes into, and in the dividend, what we're dividing into, we'll do the same thing. We start with w to the fifth power plus 3w to the fourth power minus 2w cubed. Then we don't have any w squareds, so we'll say plus w squared plus 0w squared plus 0w minus 9. Notice that we now have, in the dividend, we have w to the fifth, w to the fourth, w to the third, w squared, w to the first power, and a constant. Now everything will line up. So now, once we've done that, it's the exact same process again. We ask, what do I have to multiply w squared by to get w to the fifth power? And the answer to that is w cubed. So we multiply w cubed times w squared. We get w to the fifth power, which is what we wanted. Then we multiply w cubed times 0w. That's, well, 0w to the fourth. It's just basically a placeholder. And then w cubed times negative 2 is negative 2w cubed. What do we do again now? We subtract. We subtract, and we have w to the fifth minus w to the fifth. That's gone as always. And then 3w to the fourth minus no w to the fourth. Well, that's just 3w to the fourth. And then what do we have here? We have minus 2w cubed minus a negative 2w cubed. That's minus 2w cubed plus 2w cubed. That's no w cubes. And we'll write that there. And now we have three terms in the divisor now. So we're going to bring down this next term. Again, it's just the placeholder, plus 0w squared. Now we've subtracted, and we want to go back to the very beginning and divide again. So what do I have to multiply w squared by to get 3w to the fourth? That's 3w squared. And we multiply through. 3w squared times w squared is 3w to the fourth. And 3w squared times 0w is plus 0w cubed. And then 3w squared times minus 2 is minus 6w squared. Once again, we subtract. 3w to the fourth minus 3w to the fourth is gone. 0 minus 0 is 0. And then 0w squared minus a negative 6w squared, that's plus 6w squared. Again, we have three terms in the divisor. We're going to have to bring down both of the last terms, plus 0w minus 9. So now we start over again, and What do I have to multiply w squared by to get 6w squared? The answer is 6. So 6 times w squared is 6w squared. 6 times 0w is plus 0w. And 6 times negative 2 is minus 12. And we subtract. 6w squared minus 6w squared is gone. 0 minus 0 is 0. Negative 9 minus a negative 12, that's the same thing as negative 9 plus 12, that's 3. The degree of the remainder, which is 0, that's 3w to the 0 power, the degree of the remainder is strictly less than the degree of the divisor. Up here, the degree of the divisor is 2, so the degree of the remainder is 0, which is strictly less than the degree of the divisor 2. That means that we are done. That's all we can possibly do, and we have 3 left. We write that like this: 3 over w squared minus 2, our original divisor. And so our quotient is w cubed plus 3w squared plus 6 plus 3 over w squared minus 2.